Have you ever wondered how programming languages actually come into being? Take Ada, for example. It wasn't just invented by some enthusiast in a garage.
Right. It was commissioned by the U.S. Department of Defense, wasn't it? That seems absolutely unique for a government to announce a competition and say, guys, we need a new language.
There was a whole process: requirements, competitions, committees, an official standard. Ada is almost the only language that was systematically designed according to a plan.
But most languages are born quite differently. Usually, it's a story about one developer or a small team that wanted to solve a specific problem, to make code shorter, more convenient, or simply to write Unix.
Exactly. For example, C was created by Dennis Ritchie to rewrite Unix, Python by Guido von Rossum to write scripts in a simple language. Brendan Eich invented JavaScript in literally 10 days for a browser.
So most languages evolved from experiments, not committees. But Ada, COBOL, or ALGOL, these are different types of stories, when there's a specification first, not code.
And that's why Ada's story is so special. It was created before it started being used. It's not just a language. It's the result of a large government project with clear requirements, checks, and even competitions.
How did it all begin?
It all started with the so-called software crisis, which was particularly acute in the U.S. Armed Forces. Imagine, by 1973, the Department of Defense was spending almost half of its computer budget, that's $7.5 billion, on software development and maintenance.
Wow, half the budget on software? That's insane money. And what was the main problem?
The problem was the complete chaos of programming languages, especially in the so-called embedded computer systems, those that are an integral part of weapons, aircraft, ships.
So a bunch of different languages, their incompatibility cost huge expenses?
Exactly. In the early 70s, military systems used about 450 high and low-level languages. Many of them were created for one specific task, because no existing language was suitable for specific needs, such as real-time control.
That's a nightmare for maintenance.
Absolutely. Each branch of the armed forces had its favorite languages, which were incompatible with the languages of others. A program written for the Air Force had to be completely rewritten for the Army or Navy. Lieutenant Colonel William Whitaker, head of the working group, remembered how one program had to be rewritten 5 times due to computer replacement.
That's just incredible. And of course, all this led to huge expenses.
Exactly. Incompatibility meant significant costs for developing separate compilers, training programmers to work with different languages, and maintaining program code whose lifespan could reach 20 years. That's why they needed a single unified language.
Okay, so because of these problems, there was an urgent need for unification, right?
Exactly. In January 1975, the Pentagon created the High Order Language Working Group, or HOLWG, to bring order to this linguistic chaos.
They probably initially just wanted to choose from existing languages.
They approached the problem with ambition. The process of creating a new standard was unprecedented. It consisted of several stages.
Interesting. What were these stages?
They started with formulating requirements. Instead of simply choosing a language, HOLW involved a wide range of users and experts. Over 3 years, they developed several versions of requirements documents, which had code names: Strawman, Wooden Man, Tin Man, Iron Man, and the final standard, Steelman. Each version was refined based on feedback from over 80 review teams.
Interesting names. What does Strawman mean?
Remember the Scarecrow from The Wizard of Oz? The idea was to create an initial, perhaps imperfect version that would provoke a lot of discussion and criticism. A kind of straw man that wouldn't be ashamed to tear to shreds, to then build something stronger on its basis.
And then they got to the Iron and Steel Man.
So it was quite a long and thorough process. And why didn't they just take an existing language?
After the list of requirements expanded, it became clear that none of the existing languages, even Fortran or COBOL, could satisfy more than 75% of the specifications. This led to the decision to create a completely new language.
Understood. And then they announced a competition.
Exactly, an international competition. In 1977, an international competition was announced for the development of a new language. Most proposals were based on the Pascal language, due to the significant influence of the structured programming concept. 2 teams reached the final: green, CII Honeywell Bull, and red, Intermetrics.
And who won? In May 1979, the Green team, led by Jean Ichbia, won. The new language was named Ada in honor of Augusta Ada, Countess Lovelace, who is often considered the world's first programmer.
I'm curious, what kind of language the U.S. military wanted at that time? If we dig deeper, what did these requirements contain?
These requirements are available online. There's a whole section dedicated to general design criteria. These were a kind of commandments that defined what the future language for embedded computer systems of the U.S. Department of Defense should be.
So the basic principles on which the entire design was based?
Exactly. They identified 8 key criteria. Let's briefly go through them. Generality. The language had to be general enough, but within the needs of embedded systems. This meant real-time control, self-diagnosis, working with non-standard devices, parallel processing, numerical computations, and file processing.
It's probably difficult to create a language for all occasions, so outlining reasonable boundaries is important.
Reliability. This was priority number 1. The language had to facilitate the creation of reliable programs, prevent the creation of buggy code, and automatically detect programming errors as much as possible. Maintainability. Programs had to be easy to maintain. The emphasis here was on code readability, so that it was easy to understand, modify, and not just quickly write.
That's what Ada is famous for now.
Efficiency. The language had to facilitate the creation of efficient programs. This meant that expensive to implement constructs had to be immediately noticeable in the code, and functions simple and efficient on typical machines. The goal was to minimize execution costs. Simplicity. No unnecessary complexity. The language had to be as small as possible, but meet the needs. Minimum special cases, consistent semantics and syntax, without several ways to write the same thing.
Yes, we all strive for this from our language.
Implementability. Language features had to be understandable and implementable. The semantics of each feature had to be clearly defined so that its interaction with others could be predicted. Machine independence. The language design aimed for independence from specific machines or operating systems, although there had to be a mechanism for defining parts of programs that depend on the configuration. Complete definition. The language had to be completely and unambiguously defined. A formal definition was important for achieving all these goals.
These requirements were very ambitious and far-sighted. You know, all this sounds quite familiar. I think in the latest version of the Ada standard, which came out a few years ago, I saw the same or very similar requirements. This proves how successful that initial design was.
That's truly impressive. It turns out that what started as a response to the software crisis in the 70s laid the foundation for a language that remains relevant today and meets the highest standards of reliability.
And with that, our journey into the history of Ada's creation comes to an end. Perhaps it will make us think about how we approach software development today. Thank you for being with us, and see you in the next episodes of our podcast.